Alright, what's up everyone? This is Codeforces Round 723. It's been a while since I did a screencast, so hopefully this one will turn out good. Yeah, if you're competing, then good luck. I think I'll actually start on problem B this time. Or at least I'll read B. Well, B and C. C1. Actually, it's not loading. Hold on. Actually, no. Okay, there we go. The only difference in here is that n is small. Okay, if we use 1, 1, 1, 1, 1 that many times, then that's the same as just using that once. We just need to check to see if its digits are. No, we can't. That doesn't work. Oh, that's because we can't use a single digit one. Okay. If it's divisible by 11, if it's divisible by this, I know this value can be expressed as a bunch of 11s. Can 1, 1, 1, 1, 1, can this be expressed? No. Can it be expressed as 11? No, not quite. I hate 1, 1, 1. Let's see. If we like multiply it by 100 plus that, so it's like this, if we multiply this by 100, it's like 11100 plus 1, 1. This can be divisible by 11. So it's only 2 and 3 matter. Yeah. So we just need to make sure that if it's divisible, or I guess we need to check to see whether 11a plus 111b can be equal to n or not. Is 111 and 1, 1? They have to be positive integers. I think if n is like at least a certain size, it's always so it's like static element max is equal to, let's just say 100 for now. If we use 1 this many this, okay, let's try this. So dp at 0 is equal to true. Okay, so if dp of v, if v plus 11 is less than or equal to max, dp of v plus 11 is equal to true. If v plus Okay, yeah, that's what I thought. Only like some of the smaller values. Okay, that's great. So if n is greater than or if n is strictly greater than max, then it's always possible. Otherwise, it just uses dp stuff. If dp at n, then else. Okay, that works. And then we just check like 2, 1, 2, 3, 4, 5, 6. Yes and yes. Yeah. All right, that makes sense. If it's strictly greater than max, otherwise it fits in bounds. Running on pretest. No queue, please. Running on pretest. Okay, we got it. Problem A. You're given an array A of 2 n distinct integers. You want to arrange the elements of your array in a circle such that no element is equal to the arithmetic mean of its 2 neighbors. No element is equal to the arithmetic mean of its 2 neighbors. If they're all distinct. If they're all distinct and there's an even number of them, we can make it so that the neighbors are either like both strictly larger or both strictly smaller. So yeah, that could work. Yep, array stuff, sort array. We just print the values, right? Yeah. New int n. So for int I is equal to, I don't know, I guess dex is equal to 0. For int I is equal to 0, I is less than n, I plus equal to 2. Res I is equal to array at dex. And for and that, oh wait, hold on. Why is this not working? Oh, it's 2 times n. Okay. Well, okay, let me just submit this to see if it's okay or not. Problem C1. Let me look at C2 really quickly. Actually, let me just pull up the full problem set. Kill Anton. What? Oh my god. The problem writers have been driven insane. I get it. Yeah, Anton is quite the personality. Okay, so it's 200,000. N potions in line, potion 1 on the far left, potion N on the far right. Each potion will increase this. Oh, okay, you gain this amount when you drink a potion. You start with 0 health and you walk from left to right, from first to last. At each potion, you may choose to drink or ignore it. You may ensure your health is always non-negative. That potion will decrease will health. Huh? You must ensure your health is always non-negative. You start with 0 health and you walk from left to right, from first to last. You may choose to drink or ignore it. And you want to, okay, you want to maximize how many potions you drink. Huh. So the largest subsequence such that its sum doesn't dip below a certain value. The largest subsequence such that the sum doesn't go below a certain value. Okay, so if we just like assume we take everything. We can take everything if none of our prefixes go below 0. And if a value does go below 0, then we can just get rid of that value. Oh, I mean, it's possible that we might want to get rid of a value before as well. Oh, okay, maybe it's like we do greedy on this prefix, and then whenever we get like a negative value, we want to remove the largest negative value out of these occurring elements. Because like we have to remove one, we might as well remove the one that like the best one. Is that optimal? Yeah, because positive elements we always want to keep, and negative elements will only go negative if it's negative in the first place. Okay, I'm gonna try this. So we have this, and then we have, I guess, how do we do this? Priority queue? What's the time limit on this set? It's only 1 second. If it's only 1 second, I'll use fast scanner just to be safe. If it's only a second, I will use fast scanner. P2.add prefix plus equal to x. So if prefix is strictly less than 0, then int val is equal to pq.poll. This is guaranteed to be negative. And then we just do this. I'm gonna submit on I'll just submit on C2. I want to wait to see whether this is correct or not in case if it's not. Pretest 2, pretest 9, pretest 13, pretest 17. Okay. C1. If it works on C2, it works on C1. All right, what's the next problem? We don't know yet. Okay. Problem D. Oh, wait, hold on. F is interactive. Suffix array stuff. Kill Anton. Kill Anton. I don't want to kill Anton though. After rejecting that many data structure problems, oh my god. Anton's DNA can represent a string A which only contains the characters Anton. Only 4 distinct characters. String B which must be a permutation of A. However, Anton's body can defend against his attack. In 1 second, his body can swap 2 adjacent characters of his DNA to transform it back into A. Anton's body smartly uses minimum number of moves. Wait. Which only contains these characters. Okay, so we're given A. We want to take A and permute it so that the number of versions is maximized. Body can swap 2 adjacent characters of his DNA to transform it back into A. 2 adjacent, so it is invergent. Have they not solved it yet? 2 people have solved E. Okay, I'll read E then. D seems like... It doesn't seem super easy. You saw a suffix array. You wondered how many strings could produce a suffix array. What? Let S be a string of length n, and the ith suffix of S in the substring is this. The suffix array of this is this, as the sorted suffixes are that. Oh, I see. Okay, I see. Okay, what if it's 0, 1, 2? If it's 0, 1, 2 with n equals 3 and k equals 2. What is something that could satisfy this? Wait. It has to be like the whole string, so it's like A, B, and then B. Okay, I have a hunch for this. Only n and k matters. Well, now, I'm not sure if that's right or not, but I think it's something I could keep in mind. Score distribution is still 1 and 2. Who solved it? Okay, so then there's probably just some random people. No, whatever. How do we find this? One, two, three. I mean, obviously that's just one. This one, it's okay, so like if we have a number here, we have to take this number and then add it. In order for a longer string to be lexicographically smaller, we have to append a character that's strictly less than that. Yeah. Right, so if it's like 0, 1, 2, 3, 4, 5, 6, so like if there's 7 of them, 1, 2, 3, 4, 5, 6, 7. Okay, in this case, there's 6 letters in the alphabet. How many length letters of value 6? Let me write brute force. X1526E brute force. And n is equal to 7 and k is equal to 6. Right, yeah. So if we do int I is equal to, I guess, alphabet size. I'll replace 6 with k. This is equal to 6. Ah, there we go. A, B, C, D, E, F. Okay, so string is equal to A plus okay. We need to sort this string. So public string, public int ID, public thing A and B. Or oh wait, actually, we can just find the ID by the length of the string. Yeah, that just doesn't matter. ls.add str.substring from I up to that. Collections.sort ls. And count, or yes. I.length. Okay, so 0 is the longest one. Okay, if this length does not equal to n minus array at I, then count becomes 0. Why is this not compiling? Oh. Three to 30. What about 3 to 4, 1, 0, 5, 6? 36. Okay, so it does matter. Never mind. Okay, but this seems like an interesting pattern though. Because 0, 1, 2, 3, 4, 5, 6, what is that equal to? If it's like 3 to 30, is 3 to 30 divisible by 7? No. I mean, it is divisible by 6. 55 times 6. What about For example, if I do 1, 2, 3, 4, 5, 6, or wait, no, 0, 1, but instead I do 6 and 5. Okay, still 330. What if I do 1 and 0? 120. 5 and 6. 120. Does that only matter? Does this prefix only matter? Okay, so it's 330 if it's like 0, 6, 0, 1, 6, 5, 4, 3, 2. What would this be? 330. What if we swap this? Then it's 36. That's really weird. What about 5 and 0? It's also 36. What about if we put 2 and 3 over here? Interesting. I'm not really sure what to make of that. Okay, so it's probably not blatantly troll. Okay, and D does seem to be easier. I'll go back to D for a little bit. Let me just close that. Oh, this as well. Anton can defend against this attack. His body can swap 2 adjacent characters of his DNA transform back into A. Body smart leaves the minimum number of moves. Aragorn wants to change Anton so it maximizes the time for Anton's beauty to do this. Permute array to maximize inversions. Something like that. Okay, well, the minimum number of inversions, we can find it by for each character. If that character is the same, then we just move on. Otherwise, we find this nearest character to here, and then we add it here, and everything just gets shifted like this. So we want to find the minimum number of like shifting sequences. If it's all zeros and ones, what do we do? If we have multiple answers, it may output any one of them. a character here. This is like the leftmost position in here. Something like that. DP with letter frequencies. Find the best string for D. B must be a permutation of the string A. So we like shift this, and that's like we do on the suffix. We need to do it on the minimum. It's like a leftmost A or something. Leftmost or rightmost. Go to DP on something else. Anton. What do I not know? Okay, so it's like, oh, because that just gets shifted to 1, 2, 3, 4, and then 5. That's 5. Okay, so what if it's like A, N, A, N, A? This is 2 moves. This is 3. What about like N, A, or I guess. We never want to swap between adjacent characters. Okay. We never swap the same characters. Relative order stays the same. So if it's something like this, for example, these A's will never change their respective order. These N's will never change their respective order. Is it just that? Like A, N, A, N, A, N. What if it's like N, A, A, N, A? This is 1. Okay, well, what about A, N? Okay, this is 1. And that's 2. Okay, because if there's characters that are like split up like this, yeah, because if a character moved over here, it would have been more optimal if we were just like put it over here and then do it over here, so it's the same thing. So I think same characters must stay together. As equal. Anton. Like in here, for example, this is valid. This is valid. That's obviously valid. And over here, well, okay. The minimum number of inversions it took for this is, I mean, it's hard to see, but if it's something like, okay, our goal state is O, A, A, N, T, T, O, N, T, N, N, T. Oh, that's not necessarily true. Yeah. Because if initial string is something like AA and then TT, then doing it, well, I mean, I guess TTAA. Yeah. But what if characters like this are stuck together? inversion count. Okay, versus something like, okay, well, the state that we start with is TNNT, AOOA. Okay, so this is from here to here. This is 1, 2, 3, 4, 5. Right, 1, 2, 3, 4, 5. Wait, 1 to 2 to 3 to 4 to 5. Yeah. So this is 5 inversions, and that's O, T, N, N, P, A, O, A. Okay, and the next one is this A over here. Go 1, 2, 3, 4 inversions. So now it's O, A, T, N, N, T, O, A. Another A, which is 1, 2, 3, 4, 5. Right. 4, 5 plus 5. Now we have OAA, and then we have T, N, N, T, O. And then we have N, which is just one inversion, plus 1. And T, N, T, O. T, which is 0, so like plus 0. And then we have one inversion over here, so now it's like O, A, A, N, T, T, N, O. So plus 1, and then plus a 1 to get the goal. This is all equal to 14, 15, 17. This is equal to 17. But those ends have to... If those ends are equal to this... solve. How many people solved it? Time limit? I guess it could make sense because you have to look at every... I guess it's 4 factorial, right? 24. You look at every 4 like arrangements that are put together and count how many inversions. I'm gonna try this. I feel like it's faster to just like write the solution than it is to work that last sample by hand. Class fast scanner. Oh, crew. Cut. Paste. Problem D. So we have, okay, it's just T and then a string. guess, hold on. I guess it's 2 num. Okay. Okay, so we do this, and then all right, so we do int. Okay, so we have array and then array input. So we want to check every, I guess every permutation, right? Okay, how do we iterate over permutations efficiently? How? I guess we just do generate permutations. New array list of array list. Should they be integers? I feel like it's better if they're integers. Like integer arrays. New boolean 4. State is equal to new int 4. And DFS is perms seed in state. An array list of perms boolean seed and then int state. Or this is arrays state with -1. Yeah, because it's 0 through that. Boolean has is equal to +4 and 4. Okay, if not seen at I, then not has perms not has state.clone. Perms.add state.clone. If not seen at I, then we do has is true. Seen at I is equal to. Oh, we need the value. Yeah. 0 in val. false, and then this. Okay, that's probably right. Yeah. So we have this. What do we have then? We have how do we count inversions again? Inversions. Yeah, it's like the first digit. You're too distracting. It's 100. It's like 2.4 million. Yeah, 2.4 million is probably okay. Go back. Go back. Then we do into P and new int long best is equal to 0L. Okay, and so what we do over here is int target is equal to new int cur. Okay, so it's array at P at I. And it's like permutation of these values. Okay, so while frequency at poof cur. This is like a current. I'll let P at this, I guess. So cur I is equal to P at we need to find yeah, the number of inversions is yeah, it's like how many characters are to the left of the most recent value in here. So if it's T, then it's like number of characters in here that are not equal to T. And then like we move on. And next if it's like A, and it's like the most recent A, how many are like to the left of that in here? And like minus a certain value. I think this only works. Wait, does that work for like the general case? Probably does. Yeah. Or I guess. No. You are too distracting. Get out of here. Go. Find number inversions. We do. I guess. So 4 in x. All inversions is equal to 0L. The number of characters before it not equal to itself. Yeah. Wait a minute, but wouldn't that be an O of anyway? No, because then. Oh, because then only some values get up. Okay, yeah, that makes sense. Actually, wait, hold on. What is like count inversions in n times k? Wait, what was it again? Oh my god. It's like, you want to count, I guess, for each number. We know it's sorted order. We know it's order. But if we do it in that order, wow, I really forgot how to count inversions, huh? What is wrong with me? Shit, dude. Hold on. Does that work? Long inversion. if we do, I guess, hold on, well, no, actually it does make sense. Int order. Or I guess array ordered or ordered at array at I dot at I. So long inversions, each like tag gets added with something. So it's like Fenway tree, maybe. It's like 2.4 million times n with a little bit. Yeah, it'll probably be fine. Fenway tree. Yeah, these values will have 0 in them. So public void add I++. Yeah, okay. Do this. Increase the index by 1 because it's 0 indexed. Plus 2, so 4 int. Well, int val is equal to ordered at cur at I dot poll. Or I guess no. Array. These could be array lists, so we just have to get that value. Because this is I mean, if it's like, if we put in a small value, we want to figure out how many larger values we've already put in. So it's like bit.find val plus 1 up to including n. And if n was the largest value, then it's just 0. Yeah. If n minus 1 was the largest value, like n minus 1 to n inclusive. Or yes, n minus 1. Yeah, because we don't want to ever go above it. Even if it's equal, then it's just bit.add val 1. If s is strictly less than inversions, then conversions and res becomes per. Line 4, line 58. Oh, I need to update it. Frequency array at I++. That's not right. Oh, that's because I need to convert these to characters. I was like, huh? Like, what kind of weird thing was that? Okay. Well, this, I hope it doesn't TLE. We have two, it does give two, oh, okay, or that would work as well. Unable to make S from T, that's not right. A, N, N. Why do I have an extra A? What? Wait, there's an extra A and like, there's an extra N as, no, there's not an extra N. Wait, why is there only an extra A? What? Really? Okay, wait, hold on. If it was 1 and then it was like Anton. N-N-O-T-A. Wait, that's fine though. N-N-O-T. How did that happen? What? Wait, hold on. Something doesn't make sense here. N-N-O-T-A. Wait, that seems like it could work. Oh wait, hold on. Let me print the best value. Actually, no, I won't. Dude, I'm like all over the place right now. If we do this, we get 17. I think is correct for that test case. Running on pretest. Is there a queue? It's not that bad. Why is there an extra A? Wait, am I crazy? Like their output is giving an extra A. What? Like, do I? Yeah, because in here they're... But like when I run it on here, it doesn't have an extra A. But when I take the same code and I run it on here, Like, am I... Hold on. Yeah, there's an extra A. Maybe it's next line? What if I just do next? Wait, next will make it work. String input info out next. Okay, it was just like some weird input thing going on. That was so weird. I'm gonna go to the bathroom. Wrong answer on pretest 2. Fun. Don't you love it when that happens? What else? Straight bussin' out here. Permutation. System.out.println perms.size. This should be 24. Okay. Best less than or equal to. Oh, frick, that's why. Because, yeah, because before, if I had something like this, I mean, obviously it prints n, but if this was my old code, if I did something like 1, yeah, that's why. It has to be less than or equal to. That was pretty stupid of me. Alternatively, I could have just made best initially equal to -1. Six, pretest 10, pretest 13, 14. Okay, we got it. Time limit? That's actually really fast. Okay. That was actually super fast. All right, what's the next problem to go?